Today we're talking about systems with three variables. It's section 3.5 in your book and for your note taking. Your vocabulary is three variable systems. It's three equations with three variables. So today we're looking at equations that have x, y, and z in them. And three equations that you're going to have to use elimination and or substitution in order to solve. So your very important concepts, your goal is to eliminate two variables at once. So when you're given your three equations, you want to look at them and decide if there's any way you can eliminate two variables or anything you can multiply one of your equations by that will get rid of those two variables. Then you're going to substitute in for the variable you solve for, and you're going to do elimination to solve for a second variable. And last, you're going to plug in for your two solved variables and solve for the last variable. Example 1, we have our three equations, negative x minus 5y minus 5z equals 2, 4x minus 5y plus 4z equals 19, and x plus 5y minus z equals negative 20. If I take equations 1 and 3 and I add them together, negative x plus x, that will eliminate. And then negative 5y plus 5y, that will eliminate. So I'm going to take these two equations and I'm going to write them down here together, so that I eliminate x and y and I can solve for z. You're not always going to solve for z first. Sometimes you can eliminate x and z and solve for y. Sometimes you'll be able to eliminate y and z and solve for x. It just happens that this time we're able to eliminate these two, x and y, to solve for our z. So writing these two equations, I have negative x minus 5y minus 5z equals 2. That's my first equation. And x plus 5y minus z equals negative 20. That's my third equation. I'm adding them together. These cancel out, and these cancel out. Negative 5z minus z is negative 6z, and 2 minus 20 is negative 18. Dividing by negative 6, I get z is equal to 3. That's solving for my first variable. Then I'm going to take that z and I'm going to substitute it in for z in any two of these three equations and solve the system with just x and y using elimination. So plugging in for z, I'm going to take my first two equations. It doesn't have to be your first two equations. It could be your second and third equation. It could be your first and third equation, but this time we're using the first and second equations. Plugging 3 in for z. So I have negative x minus 5y minus 5 times 3 equals 2. 5 times 3 is 15, and we want to move it to the other side by adding it, and I get this output of negative x minus 5y equals 17. 4x minus 5y plus 4 times 3 equals 19. 4 times 3 is 12. 19 minus 12 is 7, so my second equation is 4x minus 5y equals 7 when I substitute that z in. From here, I know that if I multiply this equation by negative 1, I'm going to get my 5y's to cancel out here. So multiplying this equation by negative 1, it becomes negative 4x plus 5y equals negative 7. Rewrite my first equation. Here these will cancel out. I have negative x minus 4x is negative 5x, and 17 minus 7 is 10. I divide by negative 5, I have x equals 2 as my second answer. Now I have two variables I can plug into any equation. I can plug into this one, I can plug into that one, I can plug into the original ones because I have a z solution and an x solution. So plugging into this equation right here, I have 4 times x, which was negative 2, minus 5y equals 7. Multiplying, I get negative 8 minus 5y equals 7. Adding 8 to both sides, I have negative 5y equals 15. And dividing by negative 5, I have y equals negative 3. So this is my third answer or solution for my third variable. So altogether, I have x equals negative 2, y equals negative 3, and z equals 3. And I can write this as an ordered pair, but in a three-dimensional plane, where you have an x-coordinate, y-coordinate, and a z-coordinate. You have negative 2, negative 3, and 3 in those parentheses.